Section 7.1b deals with multiplication and division of rational expressions. So when we started this chapter, they were focused on just kind of making sure that you understood that you can't divide by 0 and thinking about what you'd plug in to end up dividing by 0. That topic, for whatever reason with the sequence, they kind of introduced that, and then they're not going to make you think about that for a little while until you get to section 7.4. Then you'll have to remember that topic again, 7.4a. So here they just want you to kind of work with the numbers, and it's going to be either a multiplication of fractions or a division of fractions. So you got to kind of remember how things worked with regular numbers with fractions back from previous math courses, previous math experience. If you take fractions and you try to multiply them together, remember that you can multiply top with top, bottom with bottom, but you have the ability to you have the ability to reduce either within the same fraction or diagonally reduce before you do the multiplication. Okay, so some people get confused with fractions for whatever reason with trying to do some type of cross multiplication. But if you're multiplying fractions, it's always straight across the top, straight across the bottom, but you can reduce either up and down or diagonally if there's things to reduce. So in this particular problem, what I see are that 16 and 2 could reduce ahead of time, 21 and 7. Let's see what the tutor mode does. Hopefully they don't contradict me in terms of process. They're saying, okay, so they're saying first, let's just recognize that we can multiply across the top and across the bottom, but they are going to leave things separate. So this is fine here. 16 n to the second, 21m squared. And this is a good reminder, I think, that this is why you can reduce anything on the top with anything on the bottom, because technically, right in one step, you could call it one fraction instead of two. So it's really just one fraction and you're reducing. Okay, so I filled in the boxes that they're asking for there. Okay, so they're going to do this out all the way, and there's nothing wrong with this either, because you're going to understand really why you can reduce what you can reduce. If you took 16 and you reduce it down to its smallest factors, you could make a little factor tree, and you could think of 8 times 2, and then 8 becomes 4 times 2, 4 becomes 2 times 2, and then you're going to have 4 2's on the bottom of that factor tree, which will end up being 2, oops, can't type, 2, 2, 2, and 2. Okay, there we go. Okay, so here's a little picture of what I was going for. When you're talking about 16 becoming 2, 2, 2, and 2, you got the factor tree. 16 becomes 8 and 2, 8 splits down to 2 times 4, 4 splits down to 2 times 2, so you've got 4 2's on the bottom, see right there. So you can fill regular numbers in if you have to split them up into these respective factors, these smallest prime factors. You can split it up with a factor tree. So I could also do the regular numbers for 21. 21 is just 7 times 3. Those are both prime numbers. So that'd be a pretty pathetic tree. You could do it out, but just 3 and 7. And then look at the variables. I got n and n squared, which is n times n, and m squared, which is m times m. Okay, and then on the bottom, I've got a 2 and a 7. I like going from smallest to largest, just as a habit. And then, well, I should have done it alphabetically before, and I've got 3 of those, either way. And then 2 m's on the bottom. squared. Alright, so if you have all those individual factors, okay, you can reduce it this way just by canceling out what's common. You know, see how they want us to do this. They have it arranged a little differently than I did. Cancel all common factors to the numerator and denominator. So I think if I, there we go, cancel a set of 2's, cancel a set of 7's, m's, I got some n's. So what's left after you reduce all these things? You've got 2 times 2 times 2 times 3, and there's going to be a single n on the bottom. So that's going to be the final question, is just what do you have left over? Based on what we have there, 2 times 2 times 2 times 3 is 24 on the top, and a single n on the bottom. Okay, here's another example. We've got 25m squared over 16n cubed divided by 25m over 4n squared. So what's different about this example compared to the previous is that it's a division of two fractions. But as long as you know how to handle this, it pretty quickly becomes like the previous example. Because you have to remember that when you divide one fraction by another, it's really the same as multiplying by the reciprocal, or the flipped fraction, that you're dividing by. So if we go to the tutor mode, that's going to be one of the first questions they'll ask, I believe, is, you know, what's this the same as multiplying by? So they have this down here, and they say it's the same as multiplying the first fraction by, and you'd make a fraction, type in 4n to the second over 25m. Okay, from here, it's one fraction, okay, or one fraction when you multiply the tops and the bottoms. So they kind of say you can leave it separate, but think about there being one bar. So when you're doing this out on paper, what you'll probably do is just, you know, have the same stuff, but you're going to multiply it on top and on bottom, kind of have it grouped in these parentheses like they do is fine. Oops, I must have missed typing in something here. 25m squared times 4n squared, 16n to the third, 25m. Okay. So if you do things out, remember the factor tree idea. You could take 25, prime factors are 5 and 5, 4 would be 2 and 2, I could put the 2's first, I guess it doesn't matter, m squared, m and m, n squared, n, and then down below, 16. Remember we did a factor tree on that before. I think I might still have that kicking around. Becomes 2, 2, 2, 2 on the bottom. Oops. So we end up with 2. This happened to me last time. 2, 2, 2, 2, 5, 5 for the 25, n, 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 and then m. Okay. Reduce common factors. It's out of time here, so I gotta be pretty quick. 2, 2, 2, 2, n, 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 5, 5, 5, 5, m, m. So what are we left with after we reduce all that down? We're left with m on top, and down bottom 2 times 2 is 4, and n.